Hi guys, today we're going to look at subatomic particles, and these are the particles that make up an atom. So let's get started. So in the back of your book, draw a labelled diagram of the nuclear model of an atom. So I've got a picture of the nuclear model here, or a simplified version, and we're going to label it. So the particles that go around the outside of the nucleus in the centre, so this is the nucleus, and these particles that was around the outside are electrons. And they are in something called a shell. You might also find this called an energy level. And this is what was discovered by Niels Bohr, if you remember back to last lesson. Now inside the nucleus we've got two different subatomic particles. We've got these ones, which we're going to call the protons, and then we've got the others, which are neutrons. Let's look at the next question. What did early scientists think the atom looked like? They thought it looked like a plum pudding. And you'll need to know that definition for your GCSEs. Now, last one. Who discovered the neutron? This was a man called James Chadwick. Okay, now you know that, it's time to get started on today's lesson. We're going to start off by looking at the different subatomic particles in a little more detail. And I'm going to give you some helpful tips of ways to remember the charges on each subatomic particle. Now we'll look at the proton. It starts with a P, and so does the charge positive. That's how you remember that protons are positive. They both start with a P. Now they have a relative mass of 1. So every proton has a mass of 1. And where are they found? What's their location? Well, protons are in the nucleus. Electrons. Now you'll notice that I haven't highlighted any particular letter in electron, and that's because they don't start with the same letter. So there's another helpful way of remembering them. Electron has two E's, so does negative. So electrons are negative. And they are very small. Their mass is what we call negligible. They don't really contribute to the overall mass of the atom. Now where are they found? They are found in energy levels or shells. And the last one is neutron. Neutrons are neutral. They do not have a charge. And they are found in the nucleus with protons. And they also have a mass of 1. So now we know what the different subatomic particles are, their charges, and where they're found. We can look at trying to calculate the number of protons, electrons, and neutrons in an element. And to do this, you're going to need a periodic table. So make sure you can see one. Now all elements are neutral. They must have the same number of protons as they do electrons. So how do we work out how many protons or electrons something has? Well, if we look at carbon, you'll see that there's two numbers, and these numbers, the 12 and the 6, tell you some information about that element. The top one is called the mass number, and that one tells you the number of protons and neutrons in a nucleus. And this makes sense because the protons and neutrons have a mass of 1, and most of the atom's mass is contained within the nucleus. So here you'll find the protons and neutrons added together. The bottom number is what we call the atomic number, and that's just the number of protons. But like we said at the top, an element must have the same number of protons as electrons. So if it has 6 protons, it must also have 6 electrons. So this number at the bottom, although it's called the atomic number and it tells you the number of protons, is actually the same for the number of electrons. Now, just to recap, let's have a think about what these mean and see if we can remember. The mass number. This is the number of blank and blank in the nucleus. I suggest you pause the video, try and fill this in, and then unpause it for the answers. Right, the mass number is the number of protons and neutrons in the nucleus. The atomic number is just the number of protons in the atom. It is also the same as the number of electrons. Hopefully you got that right, and we can move on to the next stage, which is calculating the number of neutrons in an atom. To do this, it's the mass number minus the proton number, or the atomic number. And we're going to have a look at an example here, fluorine. And the way we're going to do this is we're going to work out what's called the PEN, the protons, the electrons, and the neutrons. So let's try and do protons and electrons, and then we'll go into the harder one, which is neutrons. So if you remember our rules, to work out the number of protons, we look at the proton number, which is called the atomic number, which is this here. So protons is 9. Remember, we said that whatever the number of protons is, the electrons must be the same to balance it out. So if we've got 9 positive protons, we have 9 negative electrons, because they cancel out to be 0. Now to work out the neutrons, it's the mass number, so this number here, minus the atomic number, this number here. So that's 19 minus 9, which is 10 neutrons. Now just to go in a little more detail about this. In the nucleus, you have protons and neutrons. That's what this number tells you here. This number at the bottom is just the protons. So if we take this number away from this number, you're left with just the neutrons. So that's why we do this calculation. Now there's some for you to have a go at here. What we're going to do is pause the video, have a go yourself, and then unpause it for the answers. Okay, so hopefully you've got a periodic table and you've been able to have a go at these. Aluminium, it has 13 protons, 13 electrons, because they have to be the same, and then its neutrons is 27 minus 13, which equals 14. The next one, sodium. Sodium is protons equals 11, electrons equal 11, and its neutrons equal 23 minus 11, which is 12. Helium, protons equals 2, electrons equals 2, and neutrons equals 4 minus 2, which equals 2 as well. This one here, boron, its protons are 5, its electrons are 5, and its neutrons are 11 minus 5, which equals 6. Nitrogen, nitrogen's protons are 7, electrons are 7, and its neutrons are 14 minus 7, which is also 7 as well. Next ones, you have to actually find the symbol on the periodic table. We changed them ever so slightly. So chlorine, if you hunt that one out, you'll see that its protons are 17, its electrons are also 17, and its neutrons, slightly trickier now, this is 35.5 minus 17, and that is 18.5. Next one, oxygen, protons equals 8, electrons equals 8, and neutrons equals 16 minus 8, which is also 8. Nickel, so if you have a look on the periodic table to find nickel, its protons are 28, its electrons are also 28, and its neutrons equal 59 minus 28, which equals 31. 2 more now. Xenon, that's in group 0 of the periodic table, and that has 54 protons, 54 electrons, and its neutrons are 131 minus 54, which equals 77. Final one, bromine in group 7. Protons equals 35, electrons also equals 35, and neutrons, that would be 80 minus 35, which equals 45. Now hopefully those are quite straightforward and quite easy. I'm going to leave you with 4 questions now to have a go at. Remember to put some comments in the box below if you need some help or you're stuck in any aspects of the video. See you next lesson.